If a point moves along a circular path, for example, if we have a bicycle wheel, there's a point on the bicycle wheel making a circular path. It has both linear and angular speed. So the linear speed is the rate the distance traveling is changing, while angular speed is the rate at which the central angle is changing. So if the radius of a circular path is r, and a chosen point on the circle travels theta radians in time t, then the speed of the object is given by the angular speed equals omega equals theta over t, and while the linear speed v equals s over t, where s is the distance the object travels, so that's r times theta. We can also relate these two. So if a point moving along a circle of radius r with angular speed w, then v equals s over t. We know that s equals r times theta. We know that if we solve this, solving this for t, omega times t equals theta. So t equals theta divided by omega. So r theta divided by omega. So we can write this as r theta over 1 divided by theta over omega, which is r theta over 1 times omega over theta. So the thetas cancel and we get r times omega. So our linear speed equals the radius times our angular speed. Let's try an example. So let's say that we have a bicycle wheel. The bicycle wheel is 1 foot in diameter, and the bike travels at a speed of 10 feet per minute. Let's find the angular speed, and let's also figure out the revolutions per minute the wheels make. Okay, so what do we know? We know r equals 1. We know that the linear speed v is 10 feet per minute. So we know v equals s over t. We know that omega equals theta over t, and we know that v equals r times omega. So this one right here has both of the variables we're looking for. So that will give us our angular speed. We solve this, v equals r omega. So that is v divided by r equals omega. So plugging in 1 and 10, we have 10 divided by 1 equals omega. So that means that 10 equals omega, and that is our angular speed. We're asking for revolutions per minute. So that is the same because our angular speed is in radians per minute. So that means that revolutions per minute, well, each radian, so we have 10 radians per minute, and there are 2 pi radians per revolution. So we want to take and divide 10 by 2 pi, and that will give us our revolutions per minute. So that is 5 over pi revolutions per minute.